You're welcome back again. So we are continuing from where we stopped last time. We want to now begin to look at machine learning proper, starting with supervised learning. So last time under the introduction section, I explained different types of supervised learning we have. We have so many supervised learning algorithms, which I explained there, and one of them is called regression algorithm. So we have what they call linear regression. So we are going to be looking at a simple linear today. Okay, and basically linear regression is a technique that estimates the linear relationship between a dependent and one or more independent variable. All right. So that is just general definition, but we can now break them down to two. We have simple linear regression and we have multiple linear regression. The simple linear regression is a type of regression that which analyze which a single dependent variable analyze a single dependent variable, right? Also known as a predictor variable, is used to predict a dependent variable. This one-to-one, okay? The type of regression analysis in which a single independent variable is used to predict dependent variable. So we have one-to-one now, x to y, y to x. So, and then we also have multiple, which is an extension of simple linear that predicts a response using two or more features. Okay, two or more x now. We are passing two or more x in. So this is I'm showing here our data points that we have, and this equation of a straight line. Actually, this is error here. All right, so we have our y, which is our y-axis now here. We have our this is our x actually. This is the intercept here. All right, so this is one value of x now. Unless we have multiple, can add multiple. So this is error. So here we have in our linear regression line, this line here. Okay, that's what form this line is this equation that form this line. So what I'm saying here in essence is that we have our independent variable here, our dependent variable here, x and y. So just picture this as a normal linear graph you have maybe used to in primary and secondary school, right? Linear graph it's as simple as that. When the value of x is affected, value of y is also affected. For example, if value of x is increasing, value of y may be also increasing at the same time. So which form a linear line here. So if s is 20 here, you can trace the value of s to touch the y or to touch the line. So you can trace out the value of y at that point. So it's similarly to every point of x axis, there's a value for y axis. It's as simple as that. So now, y is, like I said, if y is our dependent variable, which we call it target machine learning, then here's our independent variable, which we call feature machine learning. So the W naught is the y-intercept of the line, which I showed you just in the equation now, and the W1 is the slope of the line, representing the effect of x on y. So what is the effect of x on y? So what the effect of fs has on y as we model, and the error, this is error term, capturing the variability in y not explained by x. When you run the model, you understand that when you visualize, you see that there are many things that y is surely showing, but which x cannot explain, x cannot capture properly. But we can see it if you can see the variability in y we look at y, but s will not provide explanation for it. So it's called error term. All right. So now we have advantages of a machine linear regression. The first one is interpretability. It's easy to understand, which is useful when explaining how model makes decisions. All right. Speed is faster to train than many other machine learning algorithms, which is true. And the predictive analytics is a fundamental building blocks for predictive analytics. And in relationships is powerful statistical method for finding relationship between variables, especially x to y, y to x, and in linear form. And the simplicity is simple to implement and interpret, and also is efficient to compute. Now, we have some the way we evaluate in linear regression, in regression generally, is different from the way we evaluate in a classification. Okay, they're not the same. So our evaluation majorly is focused on these items I listed here. You can see that we have though not all of them are used or oftenly used, but a common evaluation performance we are going to be seeing as we go on as majorly MSE, RMSE most times, and R square. So these are the major three that you'll be seeing commonly most times in many metrics of regression. But sometimes we want to use a MAE also, absolute error, if you want. It's the average of the absolute difference between predicted values and true values. The MSE is the average of the square of this difference between actual and estimated values, and also have the median value of the absolute difference between the predicted values and the true values, which is for this one. So we have RMSE, which for this one also is the square root of the value of the mean square, which we have calculated here. So, and the R square, that's a question of determination now, which is called the best possible is 1.0. So the higher it is, the closer it is to 1.0, the better. That's what I try to say. It can be negative sometimes, okay, because the model can be actually worse, okay, can down lines, can regress, okay, can decline. So we also have a mean absolute percentage error, which is called MAPI. It is the percentage equivalent of mean absolute. So all these ones are commonly used, but there are three major ones, which this one and this one and this one will be commonly used most times in majority of most of the machine learning metrics. All right, so we want to look at a simple linear regression today quickly. So just build a simple linear regression model to predict sales based on YouTube advertising spending. Now we have a social marketing team, a company that they based on adverts, right? So we want to look at what happened to the sales when we introduce different kind of advert method in the company. What happened to sales? Okay, we have let me introduce the data first. This is our data now. When I run it, I have data here. Now, this data you can see here. We have our first row display here. So we have YouTube, Facebook, newspaper, sales. So these are the major three columns that are standing as feature, and there's only one target variable here. Okay, which is our y-axis. So any one of them can be x at any time, right? Just to pair with our y sales. So what we are saying in essence is that what happened to sales if YouTube advert increases? If you increase advert on Facebook, it does it affect sales? If you increase advert on newspaper, what effect does it have on sales? What impact does it have on sales? That's what we are saying now. So that is our y should be having some changes along line as we are trying to also change the value of any one of these predictors. All right, so this one, I don't need to explain this one. I've already explained it one several times. All right, so let's just look at the relationship first. If you run it, we have our scatter plot here showing here. I just bring in our scatter plot here using our YouTube here. Don't forget our sales. Okay, our 0.7. You can use 0.5 if you want. I prefer 0.7. So our title, our label for x-axis and y-axis. Okay, and we show the grid. You can see here. So this is giving us a positive relationship now. Okay, you can see here sales against YouTube. Okay, advertising YouTube versus sales. You can see our y-axis, our x-axis. So you can trace here from here down up here, and you can trace out here for any point at all. Anyone you want to trace out, you can find the value of y sales for it. So that is prediction actually. So what it shows is a clear positive linear trend. Okay, as YouTube ad spending increases, then sales tend to increase as well at the same time. You can see that. And let's see how we prepare the model for this. If we run this now, the model now is being prepared. We want to define our S and Y targets as usual. So, but this time around we are using only one variable now, which is our YouTube. You can change it to Facebook, newspaper as you like. We are preserving the 2D structure. That's why I use the 2 block now, so that it maintain. Our data is sales, which our y-axis, our target. So we do our splitting as usual, 80 by 20. You can try 70 by 30 and see the difference in the results. So if I run this now, it will give me the result, but there's nothing showing yet because we are trying to predict now. So model. Now, what we are using our YouTube as a sole predictor now. That's what you are doing. You can change it to other one, and the test we evaluate model performance on sim data, which are our test data. So let's do the training, which I have run now. Right now, model. Don't forget this particular one has been called here. If you go up here, you see that in my this I call this first here. Let me see linear regression. So under Scikit-learn model, I have to import this. It's very important. If not, I cannot do. So I also import a mean square error and R square score. Okay, from the metrics. They are important because we need them. So you can check more on those ones and see if anyone you need, you can import them in the same line. So let's look at the result we got here. When we run this, we have a 8.54 our B naught. This is our coefficient now. Our slope is 0.4 0.04565. Right. So what I was telling us is that our series is y now. This is our formula. Don't forget our formula I showed us just now up there. That was called our y. Our y is equal to our intercept here. Okay. Our w1. Okay. Multiplied by our predictor here. Okay. So when YouTube adds her $0 baseline now, sales are approximately 8,540. No increase yet. That's what it means. So that's at baseline, B not at baseline. Okay. So but when it increase, we now passing YouTube advert to it. For every 1,000 increase in YouTube ads, we have sales increased by approximately 46.50. This 46.50, for example. Now that is how it increased. So that is essentially what we are talking about here. So and don't forget this one, just talking about the 2F, 4F means 2 decimal place, 4 decimal place. Okay, I've explained that before. So if you run this now to make a prediction, we have our calculation here is based on this. So we want to see the metrics, MSC, RMSC, and R square. Right. So our usual Y test and Y prep is passed in, and similarly here. Right. So we also run to see so in 2 decimal, and this one 4 decimal place. So in the same unit as sales. Okay. So we are around this. We are having this now 14.69 and 3.83. Then our R square is 0.6767. So what else means that 3.83 is our RMSC. Typical prediction error is approximately 3,830. That is our error. That's what it means, 3,000. Because it's by 1,000. Don't forget, our unit is $1,000. All right, that's our unit. So we are multiplying by our unit now to get this. Okay. Then R square is 0.677, which means 67.7% approximately of sales prediction explained by YouTube ads. So this is explained YouTube ads. So we are not even looking at the E now. So now because that one has been featuring in our RMSC and so on. So let's visualize the regression line now as I run it now. Okay, you can see the line here. So just plug in our S and Y here. So here we have our YouTube advert sales, our YouTube advert. These are unit sales and budget. So we run this line. We have this predicted this line. The lines you can see here. So now the red line actually shows our model predictions. This red line, okay, we call it regression line. Then most points cluster close to the line, we call it good fit. So these are points, those ones that are very close to the line are called good fit. All right, but those ones that are very far cannot be explained by the applicant. Cannot be explained by so these ones are very far points, but the close ones are minimum. So some outliers exist. This potential for model improvement. Because some outliers means those who are far, they are basically some outliers. So that is what we have basically. So you can change this one to actually to Facebook or to adverts. Let's try one and change to Facebook here. Okay, let's say we have Facebook here. Right, so things change now. So says we have to run this now. If I run this line now, and they have to come and just run this again. Now you can see that the changes already now in our coefficient. Now we have 11.3 now, and our now slope becomes 0.2 instead of previous 0.04. Now if I change it, if I run this line again, you can see this will be different. Can you see it's different now? This 26 0.26 now R square. Now If I run this now, I have to change this one now to Facebook, for example. Facebook. Then similarly, I change this one as well to Facebook. Right. So I'm trying to Facebook passwords hard now. If I run this line, I should have the new I can see Facebook password sales. I see it's different from the former one. So you can also choose the same for newspaper. For example, if I want to change for newspaper now, I can just come here and change newspaper also. News paper. Right. So I can copy this so that I can use this. I can run this line. Now, if I run this, so I can come here again and change this one. I run this again afresh. You can see it has changes now here. So I can come here again. I will run this one also fresh because I've changed my predictor. I see the difference here. So here now I can change this one to newspaper. Okay, right. I change it to newspaper. I want to say a new trend, a new trend, new line, right? So let's run this now. You can see this one is poor. Can you see? It's poor. It's not the trend is not as positive as the previous two. You can see it. It's very poor. So you can see most of the data are very far away from the red line predicted value. Can you see? So which also show us in our data here. Can you see here? RMSC here 6 points. You can see only 144 ms. So you can see the error. So which means this particular newspaper is very, very poor it doesn't have much impact in properly increasing the sales if we use it as our advert. All right, advert method. So that's done for today. I will continue from there in the next class as we look at other area of regressions. Thanks so much for listening. You can like, you can share, you can comment if anything you want to drop in the comment section. I will gladly respond to it. Thank you so much. I'll see you in the next class.